Alright, in this video I want to go over a couple questions from the Tzolk'in and Hob calendars homework assignment. So I'm going to look at number 3 specifically right now. So we have a calendar that works like the Tzolk'in, but there's 6 numbers and 4 days. Write out a complete calendar starts with 1A. So I'm going to move over here to my scratch paper. So we've got 6 numbers 1 through 6, and 4 day names. I'm just going to call those A, B, C, D. So part A here says to write out a complete calendar. So we're going to start with 1A, and then 2B, and then 3C, and then 4D. And then we need to repeat the numbers. So I'm going to go back to A, but we have 6 numbers. So instead of 1, we're going to go to 5, 5A, 6B. And then from here, we've run out of numbers. We only have 6 numbers, so we're going to start over with 1, 1C, 2D, and then starting over with name day A, I have 3A, 4B, 5C, 6D. And now notice I've, at the end of both my names, the 4th name D, and I'm out of numbers, so I've started over again. So if we look right here for how many days are in the complete cycle, this would be part B. I've got 4 times 3, there's 12 days in the cycle. All right, so I want to connect that with looking at these numbers, the 4 and the 6. We have that for part C on this problem. What is the least common multiple of 4 and 6? The least common multiple of 4 and 6. And for multiple, it has to be at least the larger number. So for multiple, the smallest possible value here would be 6. 4 does not go into 6. But notice 12. 4 goes into 12, and 6 goes into 12. So 12 is the least common multiple. And for part D, are there any combinations that are not used? We can go through and list them all out, but I'm going to have 2A, 4A, 6A are not used, 1B, 3B, and 5B are not used. 2C, 4C, 6C aren't used, and then 1D, 3D, and 5D are not used. Okay, so we're going to go look at a similar problem, number 4 on the homework. Says that now we have 3 numbers, but now we have 9 day names. So those day names we're going to call A, B, C, all the way to I to get 9 names. And if we go through the same process, write out the complete calendar. We're going to start with 1A, 2B, 3C, and now I've run out of numbers, but I have 6 more names. So in this case, I'm going to repeat the numbers here. 1, now instead of A, I've got D, E, F, and then 1, 2, 3, and G, H, I. And if I start over, I got 1, and I is the last name, so I'm back to the beginning. So here we have a full calendar right there. And notice there are 9 days in this calendar, which is the answer for part B. So I have 9 days in this calendar. And on this problem, part C, if we're looking for the least common multiple, of 3 and 9. I said in the last problem, the smallest it could be is the larger of the two numbers. And since 3 goes into 9, 9 of course goes into itself, the least common multiple is 9. So that is going to match up. And for part D, are there any combinations that are not used? The answer is yes. We've got, let's see, 1B, 1C, 1E, 1F, and 1I, just looking at the first column here. And then we have 2A, 2D, 2G, 2C, 2F, 2I. And then if we look at 3, I've got 3A, 3B, 3C, 3D, 3E, 3F, and then GHI. So let's make sure 1B, C, E, F, G, O, and 1H. So there'll be 18 over here. So I run this to connect that if we have 18 missing days, 9 days in the calendar, together that makes up 27, which is 3 times 9. So then I want to connect this with the number 5 on the homework assignment. Write a few sentences. If we have n numbers and x day names, I want to know, describe the number of days in a cycle. A complete cycle has the least common multiple of n and x. So you just need to find the least common multiple, and that will always be the cycle. So if we go back to the second question, the Tzolk'in calendar, if we had 30 names, or 30 numbers in 7 days, 30 and 7 have nothing in common, so you would just multiply these. 30 times 7, the least common multiple is 210 days. And then down here you would take 11 times 21, and that would be the number of days. Because again, 11 and 21 have nothing in common.